We will start the subject. First, I will be introducing the subject. So we have which we have already discussed in the starting. We have a system. So system is a combination of different physical components, or that can be an arrangement of different physical components which will be acting together to a system is a combination of different physical components or arrangement of different physical components which acts together as an entire unit to achieve certain objective. So that is a system. So system is a combination of various components which will be working together. So it can be a classroom, a lamp, a bike. So these all are example of a system because they have different parts and they are working together to achieve something. And when we are talking about control system, so control system, in a system, when the output quantity is controlled by varying the input quantity, then the system is known as control system. So all the systems which have variable output depending on the what input we are applying, that is known as control system. So normally all the processes are a example of control system because they are depending on input. What input we are applying, on the basis of that input we will be getting the output. Then we have a physical model, because when we represent a physical system, so we cannot represent actual physical system. So we have a assumptions which are always present in a system. So when we are assuming something for purpose of analysis, synthesis and design, we have physical models. So that physical models are actually on which we are working. So physical models, so all the physical systems for analysis purpose and for designing purpose, they are modeled as physical model, and we are working on physical models. We are not working on output. Sorry, actual models. We are working on physical models. So physical models are representation of a actual system with some assumptions. So it will be easy to analyze and easy to design, easy to synthesize. So that is known as physical models. Then we have mathematical models. So when we represent a physical model in the form of equations, generally in the form of differential equations, then they is known as mathematical models of that physical model. And then we have output quantities. So output quantities are known as controlled variable or response. So controlled variable, response, they will be known as output quantities, and input quantities are called command signal or excitations. So in a system, we have, as we already discussed in previous class, we will be having a system. Then we are applying some command signal, or that is also known as excitation. And then we will be getting an output. So that is response. So this is a basic control system example. The system is a combination of various components. We are applying some input and we are getting some output. So that is known as control system. Now we have various kinds of control system. So we classify the control systems on the basis of various techniques. So the classification of control system, broadly, these are the basic terms which we are using. And then I will define the normal terms which we are using. These are all types of networks are covered in this classification. But generally we are working on limited number of control system for analysis purpose. So depending on the hierarchy of the control system, means how the system is connected and how the system is behaving. On the basis of that, we will be defining them as open loop control system, closed loop control system, optimal control system, adaptive control system, and learning control system. Generally, we normally work on open loop and closed loop control system. Generally, optimal control system, adaptive control system, and learning control system are considered in these only. So we are normally working on open loop control system and closed loop control system. Optimal control system, adaptive control system, and learning. The name suggests optimal means when the system is optimally utilized, and adaptive means when the system has adaptive in nature, that means it can adapt to something. And then we have learning control system, which will learn on the basis of various experiments. So these all are generally covered under these. कोई कुछ कह रहा है? Then we have, depending on the presence of human being. अगर human being control system में है या human being control system में नहीं है. अगर human being है, then the system will be manually controlled system. And if it is a not in having human being, then it will be automatic control system. So we can have manual control system and automatic control system. Then again, there are classification on the basis of presence of feedback. If the system has feedback, then that is known as open loop control system and closed loop control system. In open loop, we don't have feedback. We are a system. We are giving the input. So as discussed in the previous class, open loop is an example like this. We have input, process, and then we will getting the output. And when we are talking about closed loop, we have in feedback, which will be getting, and it is applied to control the input which we are supplying to the system. So they are open loop and control loop system. Then depending on the main purpose for which we are using, electrical, mechanical, so it will be a position control system. That means if we are using that system for controlling the position, velocity control system, if we are using that for velocity control, process control, temperature control, traffic control, and many more, depending on the purpose for which we are using. So generally, we have more systems. So we are generally defining them as a mechanical, electrical, or chemical. So mechanical means position or velocity if we are controlling. If we are controlling traffic or temperature, then it will be electrical. If we are controlling the process of a plant, then it will be considered as process control system. So generally, when we are talking about any kind of control system, we are generally using these two terms. So 90% of the cases when we are analyzing, we have two types of system. One is open loop control system and second is closed loop control system. These all are to only to understand various systems, but when we are working, we will be either saying it is a open loop control system or closed loop control system. आगे वाली ये terms generally use नहीं की जाती when we are analyzing or using control system. Then we have classification according to method of analysis. So method of analysis and design, you have always heard this term linear and non-linear. So we have linear control system, we have non-linear control system. So linear control system, non-linear control system, generally these are used again and again. These are two different subjects, or you can say different categories. When 90% of analysis is done when we are assuming that system is linear. And when we are talking about non-linear control system means when we have the parameters which has non-linear properties, so that control system are normally not considered while analyzing. We are assuming that all the control system which we are using are linear control system. So 90%, but when we are talking about actual application, then you have to consider a non-linear analysis also. So there are different techniques to our analysis. So in this control system, we are only using linear control system. We are not using non-linear in this. We have different subjects for non-linear control system, that is advanced control system. So all which we study in this subject will be coming under linear control system. Then we have according to the components, if they are depending on time or not. So if the components are depending on time, then they are known as time varying control system. And if the components are not varying with time, then they are assumed as time invariant control system. So when we are talking about time varying control system, it comes under non-linear. And when we are considering time invariant, so they are linear control system. Because when the component is varying with time, then the component will behave differently with time. That means your system is not linear in nature. That means they will be non-linear. So time varying control system and time invariant control system. So time varying when the components change with time. Time invariant means components not change with time. So they are, if time invariant, then they are linear control system. And if they are time varying, then they will be non-linear control system. Then according to the type of signal which we are using in the control system. So according to the signal which we are using in that control system, continuous data control system, that means we have continuous signal, we don't have any break in between. Break का मतलब ये नहीं है कि we cannot have zero input. We can have zero input, but there are also input which is applied in the system. Discrete means we have discrete signal. We are not having continuous signal. we are having discrete signal which is applied to the system. तो जनरली डिजिटल कंट्रोल की जब भी हम बात करेंगे तो डिजिटल आर discrete data control system, and when we are talking about simple DC systems or normal processes, they all are continuous data control system. So discrete means when we are digital, the discrete data system is also known as a digital control system, because computer doesn't understand continuous signal. It will be understanding only discrete signal. Discrete means we have breaks. Continuously we are having parts. For some time we have input, then we have no input, then input, then no input, then input, then non-input. And if we are using AC, then they are also known as AC control system. That means they are modulated control system. Modulated control system means control system which are modulated input, and DC control system when we have unmodulated, that means we have continuous signal which is applied to the system. So according to the signal which we are using in a system, they are classified as continuous data control system and discrete data control system. So they are again your two basic control parameters which we are using when we are analyzing. To control continuous data control system, we will study. Discrete data control system is a different subject, that is digital control system. So that is a different, entirely different part. So we are working on linear control system, continuous data control system when we are talking about our syllabus control system part. When we go for non-linear, it is an entirely different part. Discrete, we have entirely different part. Then according to the number of inputs and output, generally we have input and we have outputs. So on the basis of that, if we have single input and single output system, then they are known as SISO system. Means we are only giving one input and we are getting only one output. When we are getting multiple input and multiple output, then they are known as MIMO system. That means multi-input, multi-output system. Normally, we understand from multi-input, multi-output system. So we will be not using MIMO, we will be using SISO for understanding purpose. Then with the help of superposition, we analyze multi-input, multi-output system. So when we analyze multi-input, multi-output system, we assume that we will be having one input and we getting the output. Then we will assuming second input and then we will getting the output. So that means MIMO is analyzed by converting it into a SISO. So one SISO is analyzed once, then second SISO, third similarly, and then we have advanced techniques which are used for combined analysis of multi-input, multi-output system. So they are multi-input, multi-output system that are MIMO, single input, single output system that is SISO. So normally we study SISO system. Then we have dampings. Anyone who can define damping? Damping क्या होता है? कोई भी?
सर जब फ्रीक्वेंसी कंटिन्यूअसली इंक्रीज होती जाए,
डिक्रीज हो,
फ्रीक्वेंसी तो डैम्पिंग का रिलेशन डायरेक्टली फ्रीक्वेंसी से नहीं है.
सर कोई वेव हो कंटिन्यूअसली डिक्रीजिंग.
यस सर, कंटिन्यूअसली रिडक्शन होते जा रहे तो उसको मतलब सडनली.
नॉर्मल अगर हम बात करते हैं, डैम्पिंग मींस व्हेन वी हैव सम पार्ट व्हिच इज कंटिन्यूअसली इंक्रीजिंग और कंटिन्यूअसली डिक्रीजिंग.
सर किस में माना जाएगा, वेव में?
हैं?
वेव में माना जाएगा डैम्पिंग या किसी और में?
नहीं, सिस्टम का जब हम, मैं बहुत सीधा सा एग्जांपल देता हूँ, आप एक फैन चलाते हो तो क्या फैन सीधे रन हो जाता है?
नो सर।
No, sir.
So it will go by some from 0 to that final value. So it will be going through a process which is having damping in the system. तो इसका एग्जांपल पे देता हूँ, ये इससे आपको समझ में आ जाएगा. We have applied an input in the system. Previously we have no input, that means our fan is 0. Now we have applied an input and this is your final speed of the fan. So when the system is reaching from this 0 to final value, the system goes through a various process. So we have various kind of damping in the system. So one is you have continuously increasing and then you settle down. Second is you have increased and your output is increased beyond your target and then it will comes down to settle. And then it can be a increase from final value, then decrease, then increase and then decrease. And then it will be continuously finally increase, decrease, and it will settle to the value. So these all are damping. How your system is reaching towards your final value, that is known as damping. So we have undamped, underdamped, critically damped, or overdamped case. So underdamped or undamped means you will be directly reaching towards your output. Underdamped means you are having oscillations in the system. Critically damped means you are getting fast result in the. Overdamped means you are over increasing the input and then you will be going towards down. We are again discussed when we are understanding how the control system will be behaving. So these are undamped, underdamped, critically damped, or overdamped. So these are according to the system, how your system will be behaving when you are going from your initial value to the final value. That is known as damping. And there are various damping which we study in detail when we are going towards time varying analysis, time domain analysis. So this is about basic control system. So now first I come on linear and non-linear control system. बहुत बार नाम सुना होगा. Anyone who can tell me what is linear and what is non-linear control system? लीनियर सुना था, मैंने ही पढ़ाया था
सर. लीनियर और होमोजेनिटी सर और सुपरपोजिशन दोनों फॉलो करेगा सर, वो लीनियर होगा.
हाँ, लीनियर याद हो तो लीनियर पैरामीटर्स और नॉन लीनियर पैरामीटर्स हमने कंट्रोल सर्किट में पढ़े थे. तो लीनियर कंट्रोल सिस्टम मींस a control system which satisfies principle of सुपरपोजिशन. कोई बता सकता है प्रिंसिपल ऑफ सुपरपोजिशन क्या होता है? Principle of superposition which says that पढ़ा हुआ है, कोई नई चीज थोड़ी है ये।
सर जो होमोजेनिटी और एडिटिविटी को फॉलो करे।
वो होता क्या है अंडरस्टैंडिंग के लिए?
सर वो टाइम तो सर
Sir, when there are more than one source, मतलब 2 or 3 sources are there, then we will take
एक ही पॉइंट पे बहुत जगह से सर अगर
we will
करंट
take
सोर्स
one
आके
particular source and we will calculate, sir.
पोजीशन।
नॉर्मल बात करें, इफ वी आर हैविंग x1 इनपुट, वी आर गेटिंग y1 आउटपुट। इफ वी आर x2 इनपुट, वी आर गेटिंग y2 output, and if is input is x1 plus x2, then you will be getting y1 plus y2 as the output. That means which says that the response to many inputs can be obtained by considering one input at a time. So that is the principle of superpositions. That means if we are applying one input, we are getting some output. We are applying second input, we are getting some output. And if we combine that input, then if the system response is combination of the previous two outputs, then that is the principle of superposition. Then second,
एडिटिविटी फॉलो करेगा।
हाँ क्या कह रहा था कोई?
एडिटिविटी फॉलो करेगा।
हाँ, that is principle of superposition. Then second is the differential equations. Describing the system is linear. तो कोई बता सकता है लीनियर डिफरेंशियल इक्वेशन क्या होती है?
सर जिसमें कोई डेरिवेटिव ना हो या जिसमें कोई ऑर्डर ना हो, सिंपल ऑर्डर 1 होना चाहिए।
नहीं,
टाइम इनवेरिएंट हो सर।
टाइम इनवेरिएंट हो। और कोई? मैथमेटिक्स में पढ़ा होगा लीनियर डिफरेंशियल इक्वेशन, नॉन लीनियर डिफरेंशियल इक्वेशंस। लीनियर डिफरेंशियल इक्वेशंस का मतलब बहुत सिंपल सा होता है। फर्स्ट इज कोएफिशिएंट्स आर कांस्टेंट। जो कोएफिशिएंट्स हैं डिफरेंशियल इक्वेशंस के, दे विल बी कांस्टेंट and they are not dependent on anything. That means सिंपल सी अगर हम बात करें 2d स्क्वायर y by dt स्क्वायर प्लस 5dy by dt प्लस 6 इक्वल टू 10। क्या ये 10t हो सकता है?
नो सर, कांस्टेंट होना चाहिए।
आउटपुट भी?
यस सर, dx बाय dv बाय dx प्लस pq इक्वल्स टू q होता है सर जनरल फॉर्म।
लीनियर जो हम बात करें लीनियर डिफरेंशियल इक्वेशन के कोएफिशिएंट्स मस्ट बी कांस्टेंट। आउट इनपुट कैन बी वेरिंग, ये इनपुट ही तो है। इट कैन हैव टाइम डिपेंडेंटली, but these terms cannot have. 2, 5, 6. The coefficient must be constant and they must not depend on each other. Then the differential equation will be considered as linear. And then last, if these two principles are satisfied, then the output varies linearly with input. Then that system is known as linear control system. And non-linear control system means a control system which does not satisfy the principle of superposition. The differential equation describing the system is non-linear and the output does not vary linearly with input. Means these three terms are not satisfied, then that system is known as non-linear control system. Then time varying and time invariant. So time varying and time invariant बहुत simple सा है. The system which parameters of the system are varying with time. If the parameter vary with time, then that is time varying system. And if the parameters are not varying with time, so the system in which parameters of the systems are varying with time are time varying system, and it does not depends on whether input and output are function of time or not. So when we are talking about parameters, we are not talking about input output. Input output का क्या time के साथ relation है, it does not matter. Only the parameters which we are using will vary with time or not, only that will parameter will consider. And time invariant system, the system in which input and output are function of time, but the parameters are independent of time and constant. So when the parameter of a control system are stationary with respect to time, that means does not change with time during the operation of the system is called a time invariant system. And if the parameter of a control system vary with time during the operation of the system is called a time varying system. In practical, most physical systems are time varying systems. But for the analysis purpose, we consider as time invariant. जैसे जब हमने सर्किट में पढ़ा था, रेजिस्टेंस भी पढ़ा था हमने, दैट विल वेरी विथ टाइम और वेरी विथ टेम्परेचर. तो हमने एनालिसिस करते वक्त उसको एज्यूम किया था कि इट विल रिमेन कांस्टेंट. तो सिमिलरली वी विल एज्यूम दैट द सिस्टम विल बी रिमेन, कंपोनेंट्स विल बी remain constant with respect to time, because all the system will be having like this property. It will remain for constant for some time, and after the passing of some time, components behavior decrease. So generally when we analyzing, we are assuming that we are operating only in this region. So in this region, your time parameter is constant. After this, your system parameters will become time varying. So we are assuming that when we are analyzing a system, we are operating in this range. So that's why all the systems which we assume are considered as time invariant system. And then we have continuous time control system and discrete time control system. So as the name suggests, continuous time, the system in which all system variable are function of continuous time variable. And discrete systems, all the system variables are discrete with respect to time. Then they are come under discrete data control system. So this is the basic examples or classifications